20 amp breaker cannot be used with number 12 wire feeding a 15 amp duplex receptacle. The reason for this is protection of the wiring. The overcurrent protection device, in this case the breaker, is designed to protect the conductor from overheating and potentially causing a fire. Number 12 or American wire gauge copper wire has a typical ampacity of 20 amps according to the National Electrical Code, specifically Table 310.15b16. While the wire itself can handle 20 amps, the 15 amp receptacle is only rated for 15 amps. If an overload occurs, exceeding 15 amps but less than 20 amps, the breaker would not trip, and the receptacle could overheat and create a fire hazard. The National Electrical Code, or NEC, is a set of standards and guidelines for safe electrical installations. It is widely adopted in the United States and serves as a basis for electrical codes in many other countries. The NEC is updated every 3 years by the National Fire Protection Association, or NFPA. Its purpose is to safeguard people and property from hazards arising from the use of electricity. The NEC covers various aspects of electrical installations, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. It's important to understand some fundamental electrical concepts. Firstly, voltage is the electrical potential difference between 2 points in a circuit. It is the driving force that pushes electrons through the circuit, measured in volts. Secondly, current is the rate of flow of electric charge through a conductor, measured in amps. Thirdly, resistance is the opposition to the flow of electric current, measured in ohms. These three quantities are related by Ohm's law, which states that voltage equals current times resistance. Overcurrent protection devices like circuit breakers and fuses are designed to protect electrical circuits from excessive current flow. These devices interrupt the circuit when the current exceeds a predetermined level, preventing overheating and potential fire hazards. Circuit breakers are electromechanical devices that automatically trip and interrupt the circuit when an overcurrent condition is detected. They can be reset manually after the fault has been cleared. Fuses are one-time use devices that contain a fusible link that melts and breaks the circuit when an overcurrent occurs. They must be replaced after they blow. The ampacity of a conductor is the maximum current, in amps, that it can carry continuously under specified conditions without exceeding its temperature rating. The ampacity of a wire depends on its size, material, insulation type, and installation method. The NEC provides tables and guidelines for determining the appropriate ampacity of conductors based on these factors. When selecting conductors and overcurrent protection devices, it is crucial to ensure that the ampacity of the conductor is equal to or greater than the rating of the overcurrent protection device. This ensures that the conductor is adequately protected from overheating. For example, if you have a circuit with number 12 American wire gauge copper wire with an ampacity of 20 amps, the overcurrent protection device should not exceed 20 amps. Using a breaker larger than 20 amps would not adequately protect the wire, and a breaker smaller than 20 amps may cause nuisance tripping. It is important to note that local electrical codes may have more stringent requirements than the NEC. Always consult the local electrical codes and the authority having jurisdiction, or OJ, before performing any electrical work. The authority having jurisdiction, or OJ, is the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, an installation, or a procedure. In many cases, the AHJ is the local building department or electrical inspector. They have the authority to interpret and enforce the electrical codes and standards in their jurisdiction. The AHJ may also have additional requirements or amendments to the NEC based on local conditions or concerns. Therefore, it is essential to consult with the AHJ before starting any electrical project to ensure compliance with all applicable regulations. In the specific case of using number 12 wire with a 15 amp receptacle, the proper approach is to use a 15 amp breaker. This protects both the wire and the receptacle. If a 20 amp breaker is used, the receptacle is not adequately protected, and an overload could damage the receptacle and create a fire hazard. When installing electrical receptacles, it is important to follow the manufacturer's instructions and the NEC guidelines. The receptacle should be securely mounted in an approved electrical box. The wires should be properly connected to the receptacle terminals, ensuring that the connections are tight and secure. Grounding is another critical aspect of electrical safety. The grounding system provides a lower impedance path for fault current to return to the source, allowing the overcurrent protection device to trip and clear the fault. All electrical equipment and enclosures should be properly grounded in accordance with the NEC requirements. This helps to prevent electric shock hazards and protect equipment from damage. There are different types of grounding systems, such as equipment grounding and system grounding. Equipment grounding connects the non-current carrying metal parts of electrical equipment to ground, while system grounding connects the neutral conductor of the electrical system to ground. The specific grounding requirements depend on the type of electrical system and the occupancy. In addition to overcurrent protection and grounding, ground fault circuit interrupters, or GFCIs, are another important safety device. GFCIs are designed to protect people from electric shock hazards by detecting ground faults and interrupting the circuit very quickly. A ground fault occurs when current leaks from a hot conductor to ground. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electric shock. When a ground fault is detected, the GFCI trips and interrupts the circuit within milliseconds, preventing a dangerous electric shock. Arc fault circuit interrupters, or AFCIs, are another type of safety device that is designed to protect against arc faults. Arc faults are unintentional electrical discharges that can occur in damaged or deteriorated wiring. AFCIs detect arc faults and interrupt the circuit, preventing potential fires. AFCIs are required in certain locations, such as bedrooms and living rooms, where there is a higher risk of arc faults. Electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are not comfortable performing the work yourself. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with the applicable codes and standards. They can also help you identify potential hazards and ensure that your electrical system is properly installed and maintained. Remember, electrical safety is paramount. Always follow the NEC guidelines and local electrical codes to protect yourself and your property from electrical hazards. When working with electricity, always turn off the power at the breaker before touching any wires or electrical components. Use properly insulated tools and equipment, and never work in wet or damp conditions. Double-check all connections to ensure they are tight and secure. If you are unsure about any aspect of electrical work, consult with a qualified electrician. Electrical codes and standards are constantly evolving, so it is important to stay up to date on the latest requirements. The NEC is updated every 3 years, and local electrical codes may have additional amendments or requirements. Continuing education and training are essential for electricians and other electrical professionals to stay informed about the latest codes and standards. By following these guidelines, you can help ensure that your electrical system is safe, reliable, and compliant with all applicable regulations. Remember that electrical safety is a shared responsibility. Everyone has a role to play in preventing electrical hazards and protecting people and property from harm. A deeper dive into wire gauge and ampacity is also important. The American wire gauge, or AUG, is a standardized wire gauge system used predominantly in the United States for the diameters of round, solid, non-ferrous, electrically conducting wire. The higher the gauge number, the smaller the wire. For example, 14-gauge wire is smaller than 12-gauge wire, and 12-gauge wire is smaller than 10-gauge wire. The ampacity of a wire is the maximum current, in amps, that it can carry continuously under specified conditions without exceeding its temperature rating. The ampacity of a wire depends on its size, material, insulation type, and installation method. The NEC provides tables and guidelines for determining the appropriate ampacity of conductors based on these factors. When selecting wires for electrical circuits, it is crucial to choose the correct gauge to ensure that the wire can safely carry the expected current. Using a wire that is too small can result in overheating, voltage drop, and potential fire hazards. The NEC specifies the minimum wire size for different circuit types and ampacities. For example, a 15 amp circuit typically requires 14 gauge wire, while a 20 amp circuit typically requires 12 gauge wire. It is important to consult the NEC and local electrical codes to determine the appropriate wire size for your specific application. In addition to the wire gauge, the insulation type also affects the ampacity of a wire. Different insulation types have different temperature ratings, which determine how much heat the wire can withstand before the insulation begins to degrade. The NEC specifies the maximum allowable ampacity for different insulation types based on their temperature ratings. Common insulation types include THHN, THWN, and XHHW. THHN insulation is a thermoplastic high heat resistant nylon coated insulation. It has a temperature rating of 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. THWN insulation is a thermoplastic heat and water resistant nylon coated insulation. It has a temperature rating of 75 degrees Celsius in both dry and wet locations. XHHW insulation is a cross-linked polyethylene high heat and water resistant insulation. It has a temperature rating of 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. The insulation method also affects the ampacity of a wire. Wires that are installed in conduit or cable trays have a lower ampacity than wires that are installed in free air. This is because the conduit or cable tray restricts the airflow around the wire, which can cause it to overheat. The NEC provides deterring factors that must be applied to the ampacity of wires that are installed in conduit or cable trays. Deterring factors reduce the allowable ampacity of the wire to account for the reduced airflow. When calculating the ampacity of a wire, it is important to consider all of these factors, including the wire gauge, insulation type, and installation method. The NEC provides detailed tables and guidelines for determining the appropriate ampacity of conductors in different situations. It is always best to consult the NEC and local electrical codes before selecting wires for electrical circuits. Proper wiring practices are essential for electrical safety. Always use the correct wire gauge for the circuit ampacity. Use properly insulated wires and connectors. Make sure all connections are tight and secure. Follow the NEC guidelines for wire installation. If you are unsure about any aspect of wiring, consult with a qualified electrician. By following these practices, you can help ensure that your electrical system is safe and reliable. Always remember to de-energize the circuit before working on any electrical components. This can be done by turning off the breaker at the electrical panel. Use a voltage tester to verify that the circuit is de-energized before touching any wires. Wear appropriate personal protective equipment, such as safety glasses and gloves. Be aware of your surroundings and avoid working in wet or damp conditions. If you are working on a ladder, make sure it is stable and secure. Never overload electrical circuits. This can cause the wires to overheat and create a fire hazard. Use a power strip or surge protector to protect your electronic devices from voltage spikes. Inspect electrical cords and plugs regularly for damage. Replace any damaged cords or plugs immediately. Keep electrical outlets and switches clean and free of dust and debris. If you notice any signs of electrical problems, such as flickering lights or sparking outlets, contact a qualified electrician immediately. Electrical safety is everyone's responsibility. By following these guidelines, you can help prevent electrical accidents and protect yourself and your property from harm.